Hello friends. In this video, we will take a look at an interesting zigbee sensor from the Tuya Smart ecosystem that has recently appeared and can be used to solve several tasks simultaneously. It detects motion, and for this, it uses not the more common infrared sensor, but a microwave radar capable of working even through obstacles. In addition, it measures light levels, as well as air parameters, temperature, and humidity. As usual, we will check its compatibility with various smart home control systems, starting with the default one, Tuya Smart, then using a gateway with support for the Matter protocol, with Apple Homekit, Google Home, and Home Assistant, as well as direct connection to Sonoff iHost, ZHA, and Zigbee 2 MQT. For Zigbee 2 MQTT, I once again had to create an external converter, and I'll show the main steps of this process. Device type, combined Zigbee sensor. Functions, motion detection, measurement of light, temperature, and humidity. Motion sensor type, 10 GHz microwave radar. Motion detection range, up to 10 meters. Coverage angle, 110 degrees. Light measurement range, 0/3000 lux. Operating temperature, from -10 to 55 degrees Celsius. Humidity, up to 99%. Dimensions, 68 by 23 by 19 millimeters. Power, 2 AAA batteries. Average battery life, 8 months. The device comes in a small cardboard box. As is often the case, everything printed on it is hidden under stickers. The packaging was slightly damaged during shipping. On one of the sides, it is marked which ecosystem and interface this specific sensor belongs to. It can be concluded that there are Wi-Fi versions and those compatible with Ulink. Here is everything that was found inside. Despite the box being slightly crushed, the contents were not damaged. In addition to the sensor, inside there was a large piece of double-sided tape for wall mounting and a paper clip, which is useful for pressing the connection and pairing button. The instruction manual is bilingual, Chinese, and English. It includes the technical specifications I already mentioned and the basic usage instructions for the sensor. All the details will be covered later in the review. The device is housed in a rectangular casing, typical for various Tuya Smart ecosystem sensors that run on AAA batteries. I have such sensors for temperature, door opening, and water leakage, with an external sensor. On the front side, there is an icon that indicates its main function, a motion sensor, and below it is the activity LED. On the back is a cover that closes the battery compartment. It is attached to the wall using double-sided tape, so the sensor itself is easy to remove, for example, to replace the batteries. Of course, I was very curious to see its internal design. For this, I needed 2 thin flat screwdrivers, which I used to extract the battery compartment along with the sensor circuit board. Even though the product title on Aliexpress stated it is a PDR, that is, an infrared sensor, from the beginning, the absence of a characteristic matte hemisphere made it clear that this was not the case. This sensor uses the Highlink HLK LD1040C. According to the manufacturer's documentation, its specifications are radar type, Doppler X-band, 1 transmitter, 1 receiver. Operating frequency, 10.525 GHz. Power supply, 3.3 to 12 volts. Viewing angle, 110 degrees plus or minus 10 degrees. Features, built-in antenna, interference and harmonic suppression, high stability. The sensor is controlled by the TLSR 8253 module. This is an SoC from Telink Semiconductor, commonly used in Tuya Zigbee devices. It features a 32-bit RISC processor with a frequency up to 32 MHz, 64 kilobytes of RAM, 512 kilobytes of flash memory, and a 2.4 GHz radio module with support for Zigbee 3.0 and BLE 5.0. Also clearly visible is a 24 MHz quartz resonator. The pairing and communication check button is located on one of the side faces of the sensor. When the sensor is assembled in its case, it can only be pressed using a paper clip. The sensor is powered by 2 standard AAA batteries. As I already mentioned, the manufacturer claims up to 8 months of operation from a single set. How it performs in practice remains to be seen. We'll start the logical part of the review with the default smart home control system, Tuya Smart. For connection, I use a Zigbee thread gateway with Matter support. A link to its review is in the video description. It will also allow me to test compatibility with other systems. The pairing went without any complications. The sensor automatically entered pairing mode after the batteries were installed, which was indicated by the blinking LED on the front of the case. And right after that, I immediately received a stream of motion detection notifications. I had to go straight to the notification settings and disable the motion notification option. At least for my usage, this option is definitely unnecessary. Let's look at the device plugin. At the top, the motion sensor status is displayed. It can show two states, motion detected or no motion. Below that is a list of other parameters, light level, temperature, relative humidity. For some reason, percent is written as a word rather than as a symbol. Then comes the event log, which is shown on the right screenshot, a list of automations, and the settings menu. Let's now go through the settings in detail. The menu starts with the battery level. If it shows 0 right after pairing, briefly press the pairing button with a paper clip and the value will update. Next is the LED switch. If it is enabled, the LED will blink when motion is detected. The presence interval is the time from the last detected motion until the status switches to no motion. It can be set from 5 seconds to 480 minutes. The radar sensitivity level for the motion sensor has 20 steps, from 0 to 19. The data reporting interval for light levels is, by default, 1 minute. This is the minimum value, and the maximum is 480 minutes. Next is the temperature unit toggle, Celsius or Fahrenheit. Temperature calibration. The scale allows you to set an offset up to 3 degrees in 0.5 increments in either direction, but from what I've seen, it only works up to 2 degrees, inclusive. Humidity calibration, up to plus or minus 10% in steps of 1%. This one works correctly. In my case, the air parameter readings appear accurate and nearly identical to other sensors I use. The general settings menu is standard, sharing access, offline notifications, adding to the home screen, firmware version check, and removal from the system. In automations, the main purpose of the featured device is, of course, to act as a trigger, an event or condition required to activate automation. For this, you can use temperature, humidity, and motion values. Naturally, these can and should be applied in unrelated scenarios, for example, to control a heater, humidifier, or automated lighting. Light level readings are also useful. They can be incorporated into lighting and curtain control scenarios. Battery level, for notifications. The unit switching event between Celsius and Fahrenheit, however, is unlikely to be useful for anyone. Interestingly, this unit switching is the only available action for this sensor in the automation action list, and is equally unlikely to be of use to anyone. As promised, let's check compatibility with other smart home systems. Let me remind you that the gateway this sensor is connected to supports the Matter protocol, which allows it to act as a bridge. We'll start with Apple Homekit. I go to the Home Settings menu, then to Hubs and Bridges. Here I have several bridges in use. I select the gateway, and then we see that there is one accessory listed. Let's check what it is. Out of all the sensor's features, only motion detection is available via Matter. Better than nothing, but I would have liked more. Battery level is also transmitted incorrectly. It shows as 1%. Matter is a universal protocol and behaves mostly the same across platforms. So in the second tested system, Google Home, the situation is completely similar, except the battery level shows as 0%. The third system where this gateway is used as a Matter bridge is Home Assistant. The sensor also appears here. Just to clarify, everything, including the Tuya Smart app, works simultaneously and doesn't interfere with one another. Here, the situation is a bit different. Visually, it's similar. Only the motion sensor and battery level appear, which shows as 0. But the motion sensor displays inverted values. Right now, While the app shows motion detected, Home Assistant reports no motion. And vice versa. It shows motion when none is actually present. This is easy to fix. The first thing that comes to mind is a template sensor that would invert the values again, but the fact itself is worth mentioning. Though this no longer concerns matter, the sensor is still connected to the same gateway. This is the standard Tuya cloud integration, which also works with regular versions of the gateways. Here, the motion sensor is displayed, and in this case, the statuses are correct, along with the sensitivity adjustment slider. I wave my hand in front of the sensor and, as expected, it detects motion and the status changes. Now it's time to disconnect the sensor from the gateway. By the way, it automatically enters pairing mode when this happens, and move on to the next compatibility check with direct connection. This is the Sonoff iHost, a controller for local smart home management. The version at the time of testing was 2.5.2. I start the device search. The controller again tries to prompt me to connect all available cameras in the network, but it also detects the sensor. This kind of display, as a 4-button switch, usually indicates an unsupported device. Here it is in the general list. The letter E in the top right corner of its tile indicates it is an end device, which makes sense since it runs on batteries. Zigbee routers require stationary power. My hunch was correct. It's completely empty here. There's not a single parameter that can be used for visual monitoring or automation. The only interesting thing, device and manufacturer identifiers, but these can be found through other means as well. I remove the sensor from here and move on to the next system. This is Home Assistant again, but now using a direct connection instead of a gateway. Let's now test compatibility with the native smart home integration, ZHA. The coordinator used is a SkyConnect USB Zigbee stick with the latest firmware as of the testing date. I initiate the pairing process. The sensor is discovered and goes through the interview. So far, things look promising, as several entities were identified. Good news. All values that the reviewed sensor can transmit have appeared in ZHA. A binary sensor for motion status, humidity, light level, and temperature readings. The battery level is also present. The only thing missing is the settings interface. Here I've turned the sensor toward the wall so that it doesn't detect motion, which is reflected in the binary sensor status. The light level has also dropped. I decided to run another experiment. Since this sensor uses a microwave radar and not infrared, it should be able to detect movement through obstacles. To test this, I placed the sensor inside a cardboard box. The box is closed, and the sensor is inside. No infrared sensor could operate in this mode. Let's see how the reviewed device behaves. This is the moment of placement. I just closed the sensor inside the box, and it's still detecting me. The light level is showing 700 lux. I move away from the sensor. After the presence interval elapses, by default 30 seconds, the sensor deactivates. But as soon as I re-enter its range, it activates again. The box is not an obstacle for it. The light level begins to drop. Now it's at 688 lux. I move away again and wait for the motion sensor to deactivate. In the meantime, the light level continues to drop. Now it's 663 lux. I return, and the sensor detects me again from inside the box. Everything works as expected. The light level continues to decrease. Now it's time to test Zigbee 2 MQTT. The current version at the time of testing is 2.3.0. It uses a network-based Zigbee coordinator based on the CC2652P module. It's not often that a device works out of the box in ZHA, even if not with all options, and doesn't work in Zigbee 2 MQTT, but this is exactly one of those cases. The device is not officially supported, which means we need to create a converter manually. That's what I'll do now. First, we'll try the easy way. For that, go to the Developer Console tab. There is a button for automatic generation of an external converter, and in some cases, it helps solve the issue. Here's the code the system generated for this device. To test it, you need to go into the add-on folder. Usually, Zigbee 2 MQTT in the root of Home Assistant. Create. If it doesn't already exist, a folder called external_converters, and inside it create a blank file with any name. I usually use the device identifier and the .jsp extension. Paste the converter code into this file. For the sake of a clean test, it's better to remove the device from the system before applying the new converter. Then restart the add-on to load the created converter and reconnect the sensor. This is how its exposure page looks using the automatic converter. For binary sensors, 2 alarm-related, tamper, and battery low notification, which weren't even present in the native app. Then we see useful data, air parameters, light level, and battery level in %. The key motion sensor is missing. Recently, in the review of a microwave presence sensor, I mentioned that when searching for a converter for it on GitHub Zigbee 2 MQTT, I found only the data point description, which saved me time while writing the converter. In this case, I found a request to add the device, but no data point info. The Zigbee 2 MQTT project website includes a guide on how to retrieve them. I'll link to it in the video description. I'll now show the main steps. You need to register on the Tuya developer website. The link is also in the video description. The sensor must be connected to the Tuya gateway and visible in the device list of the app. Next, go to the Cloud section, Project Management. I once made tutorials about local Tuya integration, where I explain project creation in detail. It's also covered in the documentation, so I won't spend time on this. If you don't yet have a project, you need to create one or open an existing one. Go to the Devices tab, All Devices, and select Debugging. Here is our sensor, currently connected to the Tuya gateway. Now we need to extract the data point description. I follow the official instructions from the Zigbee 2 MQTT website, which explain both the automatic and manual methods. The automatic one is faster and more convenient. The steps are clearly documented, so I won't repeat them here. Open the browser console. Copy the script code from the instructions and paste it into the console. The first time, the browser will warn you about the danger of running such code. Agree, and it won't ask again. Run the script. Now open the drop-down menu for data point and simply hover over each one with the mouse. That's it. Nothing else needs to be done. Then input the export command into the console, also taken from the official guide, and run it. It outputs the list of data points, number, and description as a text block. Copy this data for yourself. This is now your basis for writing a converter. Although external converters are created using roughly the same method, the process is unique to each device. Attention to detail is very important. I prefer doing everything step by step. It helps catch mistakes. Here is my first version of the converter, where I added just 2 data points, the binary motion sensor and battery level, the first and 110th respectively. After every change to the converter, it's essential to restart Zigbee 2 MQTT. Ideally, also reconnect the device. Honestly, I didn't reconnect it every time, but in cases where the scale or format changes, it's mandatory. Check the logging page to verify whether the external converter has loaded. It will look like this. If there's an error, the system will display it, and the file will be renamed so it won't load again next time. After fixing it, the file needs to be renamed back to load again. This is the first step, a basic converter with motion detection and battery level. Now, knowing the numbers and meanings of the other data points, I'll add them one by one, checking correctness at each stage. Set the logging mode in Zigbee 2 MQTT to debug during converter creation. This will produce a lot of messages, but helps identify data formats and types. Another intermediate step, I've added numeric values for temperature, humidity, and light level. Light level, by the way, took the most time to get working properly. Here is my final version of the converter, covering all data points I've found, including calibration options. This is how the final exposure page looks, with all entities, including settings. No visible errors, all switches and sliders work. Now I'll show some tests I conducted. Temperature correction. I set the scale to 3, but this is not in full degrees. It's in tenths of a degree, so I noted this in the slider label. How it works. Currently the correction is 0, and the sensor shows 23.8 degrees Celsius. I slide to +2, which adds a correction of 0.2 degrees Celsius, and the value increases to 24.0 degrees Celsius. To return to the previous value, I slide to -2, not 0, as one might assume. This subtracts 0.2 degrees Celsius from the current reading. The change is applied within 10 seconds. When correction is set back to 0, the previous offset remains, and the value does not revert automatically. Now let's test humidity. It currently shows 59%. I slide the correction to +10, and the reading changes to 69%. To return to the original value, I slide to -10. Interestingly, if you try adjusting directly into the negative range without first going positive, nothing happens. What I mean is, if there was no previous adjustment, or if the previous was already canceled, nothing changes. Current readings, 23.2 degrees Celsius, 59% humidity. Sliders set to 0. I slide them fully to the negative, and nothing happens. But if I first add a value, then subtract, it works fine. The most I've been able to subtract from the current value is 0.1 degrees Celsius and 1% humidity. That's a small quirk I noticed. The presence interval is the time between the last motion detection and the transition to no motion. It's easier to test in Home Assistant, where all entities are passed via MQTT, currently set to the minimum, 5 seconds. I've positioned the sensor so it can't see me. To trigger it, I just wave my hand. On the right, where the event history is shown, we see that the last motion was detected 7 seconds ago, and the no motion status changed 1 second ago. This matches the configured delay. A similar test with a 15-second interval. The last motion was 17 seconds ago, and the transition to no motion occurred 1 second ago, also accurate. As for the sensitivity scale, I haven't yet observed a clear difference. Longer testing will be needed. Here is the brightness history for 10 hours, including nighttime, with a 1-minute update interval. 2 small nighttime spikes correspond to dim night light being turned on. My dog likes to patrol the apartment a couple of times at night. Then you can see brightness increases in the morning. The sharp peaks correspond to light switches being used. Humidity. The graph is in wide steps. At night, the level dropped slightly. It's evident that updates are sent upon 1% changes. That's sufficient for everyday use. Temperature. Judging by the chart, updates are sent with a 0.1 degrees Celsius change. I believe this is more than acceptable for household applications. Considering its low price and wide range of features, the sensor is undeniably very interesting. My initial testing shows that it has good potential. I haven't found any major issues yet. I plan to use it in my production setup. If I discover anything new, I'll share it on my social media. That's all for now. I hope this video was helpful and interesting. I'd appreciate your likes. They help promote the video on YouTube. If you don't want to miss new content, subscribe to my channel. Links to all mentioned resources, as well as to my Telegram channels, social media, and smart home discussion groups, are in the video description. Thanks for watching. See you next time. Peace to all.